Good morning, students. I am Shomajit sir. Today I am here to deliver my lecture on topic colloids. This is from the chapter Is Matter Around Us Pure? So without any delay, let's start with the topic colloids from the chapter Is Matter Around Us Pure? So let's start. Now let's start with the topic colloids. Now at first let me tell what is a colloid, alright. A colloid is a kind of solution in which the size of solid particle is intermediate between those in true solution and those in suspension. Alright. So colloid is a solution that is the intermediate between true solution and suspension. For example, soap solution, milk, ink, blood and solution of synthetic detergent are example of colloids. So again I repeat, what is a colloid? It is a substance or it is a solution, not substance, it's a solution. What is a colloid? It is a solution which is intermediate between true solution and suspension. Examples like milk, soap solution, alright, blood and solution synthetic detergent. Next, in a true solution, the solid particles are so small. Alright, so in a true solution, the solid particles are so small that they cannot scatter or reflect light rays falling on them. So what we have learned here, in true solution, the solid particles are so small that they cannot scatter or reflect light rays falling on them. But in a colloidal solution or colloid, the particles are big enough to scatter light. Alright, so in a true solution, they cannot reflect light rays, whereas in colloidal solution they can reflect light rays because colloidal solution are a little bit bigger as compared to true solution. So if a beam of light is put on a colloidal solution kept in a beaker in a dark room, the path of light beam is illuminated and becomes visible when seen from the side. Alright. So the path of light beam becomes visible because colloidal particles are big enough to scatter the light falling on them in all directions. So the scattering of light by colloidal particle is called Tyndall effect. Again I repeat, the scattering of light by colloidal particle is known as Tyndall effect. So this scattering of light by colloidal solution, because their molecules are big enough and they can scatter light, this is called Tyndall effect. So you can see the Tyndall effect. Tyndall effect can be observed when a fine beam of light, you can see a torch from where light is passed. Alright, it illuminates light. So when I light the torch, when a fine beam of light enters the room through a small hole, alright, this happens due to the scattering of light, the particles of the dust and smoke in air. So torch is there, the path of light becomes visible. Alright, so here what happens, a fine beam of light enters the room through a small hole. Alright, so here we can see scattering of light and Tyndall effect is seen. So solution of copper sulfate does not show Tyndall effect. Mixture of water and milk shows Tyndall effect. So solution of copper sulfate does not show Tyndall effect, whereas the mixture of water and milk shows Tyndall effect. So Tyndall effect can be observed when sunlight passes through the canopy of fine desert, canopy of dense forest, right? Dense forest. So Tyndall effect can be observed when sunlight passes through the canopy of dense forest. So in a forest, mist contains tiny droplets of water which acts as particle of colloid dispersed in air. So the mist that are present in the forest in the form of tiny droplets of water which acts as particle of colloid dispersed in air. So you can see the Tyndall effect seen, right? The scattering of light can be seen to the mist. Now note, a true solution can be distinguished from a colloidal solution by the fact that a true solution does not scatter a beam of light passing through it, but a colloidal solution scatters a beam of light passing through it and renders its path visible. Alright, so a true solution cannot be distinguished from a colloidal solution by the fact that True solution cannot scatter light, scatter a beam of light, alright, passing through it, but a colloidal solution can scatter a beam of light passing through it. So colloids are heterogeneous in nature, though they appear to be homogeneous. Alright, so colloids are heterogeneous in nature, though they appear to be homogeneous. Now we can see the properties of colloids. A colloid appears to be homogeneous, but it is actually a heterogeneous. Alright, so the size of, so first point is a colloid appears to be homogeneous, but it's actually heterogeneous. Next point is the size of particle in a colloid is bigger than that or those of true solution. Alright, so the size of colloidal is bigger than that of true solution, but the size of colloid is smaller than those of suspension. Alright, so there is a, so this colloid are in present intermediate between true solution and suspension in terms of size. Alright, so it is between 1 nanometer and 100 nanometer in diameter. Alright, so the particle of most of the colloid cannot be seen even with microscope. So the particles of most of the colloid cannot be seen even with a microscope. So it scatters a beam of light passing through it. So first one, colloid is a heterogeneous. It appears to be homogeneous, but it's heterogeneous, and the size of colloid is between true solution and suspension, and it cannot, third point is cannot scatter the beam of light, and the particles of colloid cannot be seen under the microscope. So next, as I have already discussed, that the particles of most of the colloid cannot be seen even with a microscope. Alright, so it scatters a beam of light passing through it. Alright, it scatters a beam of light passing through it. Colloid, alright, colloid scatters the beam of light passing through it. Next, one note I have given, there is a special technique known as centrifugation that can be used to separate a colloidal particle from a colloidal solution. So centrifugation is a technique, alright, so centrifugation is a technique in which it is used to separate colloidal particles from a colloidal solution. So the component of a colloidal solution are the dispersed phase and the dispersion medium. Alright, so the component of a colloidal solution are the dispersed phase and dispersion medium. The solute-like components or the dispersed particle in a colloid form the dispersed phase, and the component in which the dispersed phase is suspended is known as dispersing medium. So colloids are classified according to the state of solid, liquid and gas of the dispersing medium and dispersed phase. So you can see what is dispersed phase and what is dispersing medium and the type and example. So if the dispersed phase is liquid and dispersing medium is gas, then type is aerosol. So example is fog, cloud, mist. Next, if the dispersed phase is solid and the dispersed medium is gas, so its type is aerosol. That is smoke, automobiles exhaust. Again, if the dispersed phase is gas and the dispersing medium is liquid, type is foam. Example is shaving cream. Next we have dispersing phase liquid, dispersing medium is also liquid. Then type is emulsion. Example is milk and face cream. Next dispersed phase is solid, dispersing medium is liquid, and the type is solution. So example is milk of magnesia and mud. Next we have dispersed phase as gas and dispersing medium as solid, type is foam. Example is sponge, pumice. Alright. Next dispersed phase we have liquid and dispersing medium as solid, so the type will be gel. Alright. So example is jelly, cheese, butter. Next we have dispersed phase as solid, dispersing medium as solid, and the type is solid sol. So example will be colored gemstones, milky glass. So student, these are the homework questions that I have given. Define colloids, write the different properties of colloids, And what is Tyndall effect? Thank you, student. This was all about the entire video lecture. I have discussed about the topic colloids from the chapter Is Matter Around Us Pure? So this was all about the entire video lecture. Hope you have understood it. So I am Shomujit Poddar signing off for today, and again we'll meet in the next class. Thank you, students.